Hey friends, welcome to the YouTube channel All About Electronics. So in this video, we will discuss the Y parameters of the two-port network. Now as I said in the earlier video, in the two-port network there are 4 variables. That is V1 and I1 on the port 1 side, while V2 and I2 on the port 2 side. And out of the 4 variables, the 2 variables are the independent variables, while the remaining 2 are the dependent variables. So for the Y parameters, the voltage V1 and V2 are the independent variables, while the I1 and I2 are the dependent variables. That means I1 and I2 are the function of V1 and V2, and they can be expressed in terms of the V1 and V2. So for the Y parameters, the I1 can be expressed as Y11 times V1 plus Y12 times V2. Similarly, the I2 can be expressed as Y21 times V1 plus Y22 times V2, where these Y11, Y12, Y21 and Y22 are the proportionality coefficients, and they are known as the Y parameters of the two-port network. Now, these expressions can also be expressed in terms of the matrix form. That is, I1 and I2 is equal to matrix of the Y parameters times V1 and V2. Or simply it can be represented by I is equal to Y times V. So now let us see how we can find the individual Y parameters. So these individual Y parameters can be found by short circuiting any of the two ports. So first of all, let us make this V2 is equal to 0. That means this port 2 is short circuited. So in this condition, the first expression can be written as I1 is equal to Y11 times V1, or we can say that Y11 is equal to I1 divided by V1, and at that time this voltage V2 is equal to 0. Now if you see the unit of this parameter, then it has a unit of admittance, and in fact that is why it is represented by the symbol of Y. So here in the numerator there is a current on the port 1 side, while in the denominator also there is a voltage on the port 1 side, and in fact that is why here the subscript is 11. Also while finding this parameter, here the port 2 is short circuited. So this Y11 is known as the short circuit driving point admittance, or simply the input admittance of the port 1 when the port 2 is short circuited. Similarly, when voltage V2 is equal to 0, then from the second expression we can write I2 is equal to Y21 times V1, or we can say that this Y21 is equal to I2 divided by V1 when this voltage V2 is equal to 0. So here this current in the numerator is on the port 2 side, while the voltage in the denominator is on the port 1 side. So this Y21 is known as the forward transfer admittance of the two-port network, because this parameter relates the current on the output side with the voltage on the input side when the port 2 is short circuited. Similarly, when the port 1 is short circuited, or when voltage V1 is equal to 0, then from the first expression we can write I1 is equal to Y12 times V2, or we can say that this Y12 is equal to I1 divided by V2 when this voltage V1 is equal to 0. So as you can see, this parameter relates the input current with the output voltage, and while finding this parameter, this port 1 is short circuited, and that is why this parameter is known as the short circuit reverse transfer admittance. And likewise, with voltage V1 is equal to 0, from the second expression we can write this current I2 is equal to Y22 times V2. That means Y22 is equal to I2 divided by V2. And while finding this parameter, this voltage V1 is equal to 0. So this parameter is known as the short circuit driving point admittance, or simply the output admittance of the two-port network when the port 1 is short circuited. And here is the representation of all 4 parameters. So as you can see, all the parameters have the unit of admittance. And while finding all these parameters, either input or output port is short circuited. So these Y parameters are also known as the short circuit admittance parameter. So now let us see the equivalent circuit of the two-port network in terms of the Y parameters. So in the first expression, this current I1 is the incoming current to the port 1, while this Y11 V1 and the Y12 V2 represents the output currents. So if we represent this equation in terms of the equivalent circuit, then it will look like this. So as I said, here I1 is the incoming current, while this Y11 times V1 and the Y12 times V2 are the outgoing currents. So here this Y12 times V2 is the dependent source, and to be precise, it is the voltage controlled current source. So in this current source, the value of the current depends on the voltage at the port 2. Similarly, from the second expression, we can say that here this current I2 is the incoming current, while this term Y21 V1 and the Y22 V2 are the outgoing currents. So in this second expression, this Y21 times V1 is the voltage controlled current source. So this is the equivalent circuit of the two-port network in terms of the Y parameters. Now similar to the Z parameters, let us see the condition of reciprocity and the symmetry of the two-port network in terms of the Y parameters. And first of all, let us see the condition of reciprocity. So let's say we have applied the supply voltage Vs at the port 1 and we are measuring the short circuit current at the port 2. Now if the network is reciprocal, then we should get the same short circuit current at the port 1 when we apply the supply voltage Vs at the port 2. Or in other words, a network is said to be a reciprocal if the ratio of excitation at one port to the response at the other port is same if the excitation and the response are interchanged. So in terms of the Y parameters, the two-port network is said to be a reciprocal if the Y12 is equal to Y21. So if we know the Y parameters of any network, and if this condition gets satisfied, then we can say that the given two-port network is the reciprocal network. So now let us prove this condition. So let's say we have applied the supply voltage Vs at the port 1 and we are measuring the short circuit current at the port 2. That means here voltage V1 is equal to Vs while the voltage V2 is equal to 0. And here this current I2 is equal to minus I2 dash. So using this, we can write the second expression as minus I2 dash is equal to Y21 times Vs, or we can say that voltage Vs divided by I2 dash is equal to minus 1 divided by Y21. And let's say this is the expression number 1. Similarly, now let's say the voltage is applied at the port 2 and the short circuit current is measured at the port 1. So in this condition, the voltage V2 is equal to Vs while voltage V1 is equal to 0. And in this condition, this current I1 is equal to minus I1 dash. So using these conditions, we can write the first expression as minus I1 dash is equal to Y12 times Vs, or we can say that voltage Vs divided by I1 dash is equal to minus 1 divided by Y12. And let's say this is the second expression. So if the two-port network is reciprocal, then these two ratios or the equation 1 and 2 should be equal. Or we can say that the Y21 should be equal to Y12. That means if this condition gets satisfied, then we can say that the network is reciprocal. So similarly, now let us see the condition for the symmetry. Now as we have discussed in the previous video, a two-port network is said to be a symmetrical network if the ratio of voltage to the current at one port is same as the ratio of voltage to the current at the other port when one of the port is open circuited. Or in other words, if the network is symmetrical, then the ratio of V1 and I1 when I2 is equal to 0 should be same as the voltage V2 divided by I2 when current I1 is equal to 0. So now let us find the condition for symmetry in terms of the Y parameters. And for that, first of all, let us find the ratio of V1 and I1. So while finding this ratio, we will assume that the current I2 is equal to 0. So from the second expression, we can write 0 is equal to Y21 times V1 plus Y22 times V2. Now here, as we are interested in finding the ratio of V1 and I1, so we will find the expression of V2 in terms of the V1. So from this expression, we can say that voltage V2 is equal to minus Y21 divided by Y22 times V1. So let us put the value of V2 in the first expression. That means current I1 is equal to Y11 times V1 plus Y12 times minus Y21 divided by Y22 times V1. Or we can say that I1 is equal to V1 times Y11 times Y22 minus Y12 times Y21 divided by Y22. Or we can say that the ratio of V1 and I1 when current I2 is equal to 0 is equal to Y22 divided by Y11 times Y22 minus Y12 times Y21. And let's say this is the third expression. Similarly, to find the ratio of V2 and I2, let us assume that the current I1 is equal to 0. So from the first expression, we can say that 0 is equal to Y11 times V1 plus Y12 times V2. And here, as we are interested in finding the ratio of V2 and I2, so we will find the expression of V1 in terms of the V2. That means V1 is equal to minus Y12 divided by Y11 times V2. And if we put the value of V1 in this second expression, then we can write current I2 is equal to Y21 times minus Y12 divided by Y11 times V2 plus Y22 times V2. Or we can say that I2 is equal to V2 times minus Y12 times Y21 plus Y11 times Y22 divided by Y11. That means the ratio of V2 and I2 is equal to Y11 divided by Y11 times Y22 minus Y12 times Y21. And let's say this is the fourth expression. So if the network is symmetrical, then the ratio of V1 and I1 should be equal to V2 and I2. Or in other words, these two expressions should be equal. So we can say that if the network is symmetrical, then Y11 should be equal to Y22. So this is the condition of symmetry for the two-port network in terms of the Y parameters. That means if we know the Y parameters and if this condition gets satisfied, then we can say that the given network is the symmetrical network. So this is all about the Y parameters. But I hope in this video you understood how to find the Y parameters for the two-port network. So if you have any question or suggestion, do let me know here in the comment section below. If you like this video, hit the like button and subscribe the channel for more such videos.